Hello everyone, this is Mohamed from Python Ninja YouTube channel and welcome to the first tutorial related to data-oriented programming. What we introduced so far in the previous 15 tutorials or 16 tutorials related to behavioral oriented programming, where we are interested in the method and behavior of the object more than the data, but now we will be more focused about the data-oriented programming, where we can create instance from the data itself. In object-oriented programming, the object class can be either behavioral-oriented, which represents the behavior of the object, as in designing machine learning models or classifier or regressors, in which we have a class and we have a different method that use to fit or predict the outcome. These methods are used to simulate or to mimic the behavior of the algorithm, okay? And any other real-world object that models the behavior exposes methods. So when we use the object-oriented programming to model the behavior, then we give our attention towards creating methods, like in machine learning we use fit and predict, okay, to process the model and give me the result or the desired output. On the other hand, in the data-oriented class, the object is the data itself. So here is the difference. So we have on one hand the behavioral oriented programming, okay, in which the class represent the behavior of the object. If it's classifier, if it's a car, for example, we can build a class for car, for a factory, for whatever we build the class for. If the class will comprises method that model behavior, okay, and actions of any object, then this is behavioral. But if the instance is the data itself, okay, then we will have the data-oriented class. The data class represent, or data classes represent any data structure, irrespective if it's vectors, points, string, or any primitive data structure. The data class and their genders or magic or their special methods, okay, help us to build and make instances from the data-oriented class or from the data class itself. There are many mechanisms that make the data classes useful. Okay, so why the data class is useful? Because we can define the data structure easily. Okay, at the beginning, when we define the attribute, we can give annotation to this attribute, and we can also follow the desired structure we have. Also, we can convert the data, if it's like integer, if it's float, or whatever it is, we can convert it directly to string without introducing a special method like the gender str we used in previous tutorials to print the information from the class. Another thing that we can compare objects together to can see if both objects hold equivalent values, and we also can make object initialization easily. Data classes, remember that data classes use class attributes, not the instance attributes. So meaning that we can override the init, or we can overlook to that init constructor. Okay, so the class attribute is used, okay, to represent the instance attribute. Now we will see we will see how the data class attribute are used instead of the instance attribute, or to represent the instance attribute. Now let us just start by highlighting example from the behavioral oriented programming. So if I have an employee, and in this I will have a constructor. Remember, what I'm typing now is not a data class, it is a behavioral class. Just I want to show you the difference between the behavioral class and the data class, and I will have the address here. As usual, we store name, okay, the value of the name, and store the value of the address, okay. in this address. Okay, and I will do nothing. Just I have two attributes, and I will define externally a function to make objects. So I will not make the direct object now, and will say, for example, employee1 will be an instance from the employee, and I will give, for example, my name, and I will give a city. It could be any city. Okay, then I will print the instance itself. Remember, this is equivalent to what we did in the past, but now I want to move to another level when we will have a function, and the function will create the instance, and I just make the instance from outside. Okay, now as you see here, we did the instance. We create instance from the behavior class, and when I print this instance, it print to me the memory address. Okay, but we also learned together that if I integrate to this class, which is the behavioral one, the str method or dunder, okay, then I can print the information rather than printing the memory address. So please go back to special method tutorial and you will learn more. And now if I use the str method, then I can, for example, print self.name. Okay, and for example, I want to print the address here, and for this address, I want to recall self.address. Okay, and now look at this. I have here print to that instance, and now I have, instead of having the memory address and the result, I have now what we recalled from the str object. That is for the behavioral class that we have. What is the main challenge of this method of this class? Okay, since it's behavioral, each time I have to change, or each time I will have a new attribute here. Okay, I have to modify the self. For example, if I will have, for example, self.married equal true. Okay, if I will execute this, then the information will not appear to me unless I will add this, okay, which will be, for example, married here. Okay, now why data class? Data class will help me to relax this str. Well, I will not use str. Okay, I will use the data class, which is a footprint different than this what I used. But remember, that doesn't mean data class will compensate the behavior class. Behavior class is used to model the real world object that have behavior, that have methods, that have action based on methods. Okay, but data class is another branch that is related to the data itself. So you cannot like neglect the behavior class and go to data class, okay, or vice versa. So remember that each time when we add a new attribute to this behavior class, we have to add that to the str to print this. And now we will start coding the data class. Remember that this str is mandatory for the behavior class, but for the data class, the wrapper will be used. You know, the wrapper, we also introduced that wrapper in the special method tutorial. Go back, and this wrapper will show you the result, not look like this. It will be the debugging mode result or the developer orientation result. Okay, so I will just keep this to have a comparison, for example, between this class and the other class. So let us also add married here, and sorry, what should be here inside the string? I would say married equal self dot married. So this is the first class, which is the behavior class. What if I want to have data class? If I want to have data class, I will I will import from data classes. Okay, module. I will import data class. Okay, data class. Sorry, data class. But here, yeah, I have to import from. No, it is scientific error. Import data class. Okay. Now, this is the first step is to import the data class. The second step is to use data class decorator. Later, you will know more about designing this decorator. Just use this. Okay, when you use at sign, okay, then you use the name of the decorator. Okay, then you use data class decorator. Okay, this is the second step. The last step is to build the class. So I will to build the class, for example, employee underscore, for example, D. Okay. Now I will not look to this in it. Okay, because the constructor will be overriding. Okay, and I will not use the constructor here. Okay, so the data class helps reduce the complexity by overriding both init and str. We will see now how that's possible. So I will make. Also, remember now, under the class directly, we add what is called the class attribute, as what we learned in the behavior class. So I want to insert the behavior, the data class attributes here. And remember, for this comment, data class use the class attribute to represent the instance attribute. So I will have no constructor, and I will use the data class. Now, remember that in data class, we use the type annotation commonly. So when you start defining your attribute like name, then you use colon, then you use str, meaning that you define this type of attribute to be string. Okay, and I will use, for example, this type, this another attribute to be of type string also, which is the address. Okay, so I have now the name and address. Okay, just okay, by this way we created data class directly. Okay, and I will make instance. Okay, I will define the same thing. I will make object, for example, D from the data class, and I will do the same. Okay, employee1 equal employee that come from the data class. I will have, for example, Ali, and I will have, for example, another city which is Roma. Okay, and now I want to call the data class here. Okay, and now let us execute. Sorry, because I have a mistake here. Now remember that here I didn't print the A and B1. I have to print that, and now you can see I have now this form which is in a rubber form. Please go back to the special method tutorials that we introduced before to know more about the rubber and str. And in the above line, it is the str which taken from the behavioral class. Okay, behavioral class, and this str is like useful string representation to the end user, to me, for example, or to you. But this is how the debugger, okay, and or how the interpreter, so the Python can see this, or how the developer prefer to see. Okay, now without using any str, okay, I defined a data class to me here just directly by defining the attributes, and I created the instance. So look at this class, how it's simple. Okay, and look to the top, a class that related to the behavior class. Okay, and also we can add another attribute as what you want. Okay, for example, I can say here is the married, for example, and this will be taken from Boolean. Okay, because it will be true or false. Later in the next tutorial, you will learn how you can give also assign default value for this attribute, And for example, if I want to say true, then I have married true directly added when I printed the instance without the need to have str. Okay, and that's the difference between the data class and the behavioral class. In the top, I have a behavioral class in which I introduce the constructor to identify the instance attribute, but for the data class, I define the instance attribute directly within the class attribute region. The second thing that I have to introduce the str method or rubber method, so I can replace this by rubber, for example. It's directly okay. Use if I want to use rubber, I can use rubber. So instead, and data class rubber is directly embedded, and no need to identify this one. Each time in the data class you modify or change the attributes, that will give you directly the update to the result here, to the output or to the display. But in the behavioral class, you have to impose that by your hand. See you next tutorial, and in the next tutorial, we will introduce the default value of the data class. How can we assign, for example, default value here, or if we have a set or list of emails, how can we give the default value for them? Thank you.